Okay, great. Thank you. So hello, everyone. This is Hassan, and I'm a recent PhD graduate of Stanford University, where I was honored to work with Dr. Martin Fisher at Center for Integrated Facility Engineering. I'm quite grateful to Dr. Ku and other organizers at kicem. One fun fact for you, Dr. Ku and I are actually academic siblings in that we share the same PhD advisor. Before starting my work at ICCEPM, I was actually quite inspired by some of the work coming out of ICCEPM, one of which was Dr. Ku's paper on 4D CAD, which was quite innovative at the time. So you can imagine how excited I am to be here. Today, I'm going to talk to you about the applications of blockchain-enabled smart contracts on the visibility of construction supply chain, and in particular, when it comes to construction payments. So when we're talking about payments, we're looking at the flow of products and the flow of cash in construction supply chain. So why do we need visibility in payments? Let me give you an example. So in construction progress payments, you basically have some scopes of work that are completed at job sites. You have different subcontractors that are responsible for that execution. They all work with a general contractor, which is in contract with an owner. So progress payments are basically compensations that the owner provides to all the trades for that scope of work. So this is quite valuable data, because if you look at progress payments, you know what payments were made, how much the work was valued, when the work was performed, and it really shows you the inner dynamics of a construction project. But the thing is, depending on who you are and what information you need, sometimes you don't really have the ability to retrieve that information. So let's look at two examples of the owner and the general contractor. If you're the owner, you might, for example, want to know the impact of a design change on project cost. Let's say you have to build an additional 20 columns on the concrete columns on a construction project, and you're wondering how much additional you have to pay. As a general contractor, you're working with the subs, so you want to make sure they're actually getting paid. So as these two parties go about looking at payment data to answer these questions, they would need to look at payments from three different perspectives. Looking at product, what is constructed, trade, who does the work, and time, for what period of work. And sometimes you have to be very detailed, ask a particular question, and sometimes you have to look at a 10,000 foot view. So you have three factors. Sometimes you are very granular, sometimes you're not. When it comes to product, being granular means asking about particular elements, cost codes. When it comes to trade, being granular means asking about a particular trade or subcontractor. When it comes to times, it could go from anywhere from weeks to months. So for example, let's say you're the owner, you want to know what's the cost of each concrete column. That's something we currently don't have, right? So you would need to look at a particular scope of work, concrete columns. You would need to look at maybe two subcontractors that are working on a column, so you fall on the right side of this spectrum. And you don't really care that much about the time. You need to know all the work that went into this particular work, so you fall on the left side. If you're the GC, on the other hand, you're looking at monthly payments to subs. So you're looking at all scopes of work, all subcontractors, and 4 weeks. So if you look at this spread, depending on who you are and what information you need, sometimes you need to be very granular and asking questions about payments. Sometimes you don't have to be. And what's the problem here? Well, the problem is we don't really have that much of a granular documentation of payments. Construction is chaotic. You have many observations of what goes on a construction site. And at the end of the day, you would use payment applications to aggregate all your observations under a payment application and submit that to the owner. So the way it works in the US, for example, is you would have the general contractor that submits a monthly payment application to the owner, which then results in a payment. What do they look like? Well, here's one example of a payment application. You would have all the valuations of work. So for example, in this case, installation, framing, so on and so forth, for the month of June. You would do that every month. So you make observations, you aggregate, you submit to the owner. The problem is this aggregate view only gives you partial visibility into your payment data. So for example, going back to the same example, sometimes if you're looking at a 10,000 foot view, let's say all scopes of work and all subcontractors, you can definitely retrieve that information. Sometimes you definitely cannot. And there's times where you may or may not, depending on how people documented the data. So what we see is a problem of partial visibility, which is quite significant for construction. McKinsey & Company actually identified if we are able to improve contracting practices, we can improve productivity. There's a lot of problems that happens when we have partial visibility, lack of trust, and this leads to late non-payments. So one of the things I knew going into my PhD is today we have a very digitalized and granular progress data. In my master's research, for example, I use robotics and artificial intelligence to really identify different scopes of work constructed. So the question I was asking is, if we have that granular data, why is it that we cannot directly use this data to pay different trades? Why is it that we cannot go from here to here? Because you would assume if we go from granular progress data to payments, maybe we can improve visibility. And here's where smart contracts and blockchain comes into the picture. If you were to go from progress data to payments, you can't use your current payment applications because they're not compatible with this data. So you would have to turn your contract into a digital format, basically a piece of computer code. So this has to be run on a computing node, and you basically have two options. One is to put it in a centralized execution model, which we call a server client, or you could put in a decentralized execution, which we call a smart contracts. So smart contracts, there's nothing smart about them. These are basically very dumb pieces of code, if-then, that are executed in a decentralized way. And I'm going to show you how it actually works. So this is going to be my attempt at a smart contract 101. So in a centralized execution or a server client, you have the same project parties. They're working with banks, and we have to assign one of these parties the responsibility of running the contract. So we give this person the code, we capture some data, this person runs the code, and this person tells us how much payments are due to what party, and then we talk to the bank. Again, we capture some progress data using drones or whatever measure. This person runs the code, talks to us, we understand how much payments are due, and then we talk to the bank. So this is a centralized execution model. Alternatively, you could use a smart contract. Again, you have the same parties. This time, they actually have access to a world computer, which we call, in this case, Ethereum virtual machine. You can think of this as a large number of independent competing nodes or miners. So these are completely independent. We're not part of that network. We work together. We write that contract. We verify that this reflects our agreements about payments. We push this to this world computer, and it gets duplicated across all different nodes. So every time we capture data, this computing node runs the code. Everybody runs the code. They reach consensus, and then we receive payments. Again, we push some data. They run the code, and they tell us how much payments are due. And because you can't really spend maybe your cryptocurrencies, you would eventually talk to your banks and exchange that for dollars. So I would like to distinguish a few things here. First off, look at who gets to execute the code. In a decentralized way, you don't have gatekeeping. So you don't have to rely on that particular party, which gives you reliability. So the whole point of smart contract and blockchain is actually reliability at the expense of being inefficient. So smart contract is actually a very inefficient way of reaching consensus. If you look at the role of banks in the decentralized way, they're peripheral. So we don't have to involve them for every transaction, and that gives us a possibility of integrating supply chain flows and potentially achieving visibility. So now that we understand the role of a smart contract, let me show you one implementation that I have developed in my research. It starts with you capturing data and storing it off the blockchain in an IPFS network. IPFS is actually a way of storing data that's based on blockchain, where you can refer to data by what it is instead of where it sits. So instead of giving people URLs, which would potentially jeopardize the integrity of data, if you put it on a public blockchain, we would have a hash of the data. So it's a very innovative way of storing data off the blockchain. We don't actually have to put the data on the blockchain. So we push some references and valuation to work through this smart contract, which actually lives on that world computer or EVM. And this also runs on the Ethereum blockchain, which is a public blockchain. Eventually, it would result in some payments. I'm not going to get into the technical details. For those of you that are interested in the technical aspects, I'm going to share with you some links to the papers which you can read. But let's say at the end of the day, it results in payments that are in Ether, which is the native cryptocurrency of Ethereum. You can also use other standards, for example, ERC21 token. So far, we know that we can go directly from progress payments to from progress data to payments using smart contracts. And the question is, could this improve visibility? And that's a question I explored in my PhD research, in that the question is, if we have a conventional payment system, the best thing we have in the industry, which is a digital platform, and we have one on the blockchain, which one would be more visible when it comes to payments? And I would ask that question at different levels of information granularity. Let's say you need a 10,000-foot view of projects. Would blockchain be better or worse? If you need a more granular question, would blockchain be better or worse? So at its core, this is basically a comparison of two systems. We need to collect some data, push it to do two different systems, and actually test it. So this is a case study I used in Toronto, where I had the opportunity to actually capture data using an unmanned aerial vehicle and photo scans, and for the period of few months. I pushed all that data to a computer vision system that I had developed in my master's research, which gives you very detailed granular data about what scopes of work are completed. In this case, it was indoor finishing work. So far so good. We have two systems. We have some case study data. One time we push it to the conventional system, which is actually a software solution industry. This is a state-of-the-art digital platform. It gives us 3 payment cycles because cycles are monthly. Another time we push it to this blockchain-enabled solution, which is just one implementation that I have. And that gives us 406 transactions written to the Ethereum blockchain. All these payments, whether it's a conventional blockchain, are showing you the valuation of the same project, which happens to be indoor finishing work for 4 different trades. And then we would basically visualize that using 2 different dashboards, which I try to make them as similar to each other as possible. The first dashboard is actually mimicked based on that best industry solution out there. So finally, we need to basically compare these 2 different dashboards in terms of visibility, which I use the charrette test method, which is something developed at SciFi. You basically have 2 different tools, one conventional, which you see here. This is what that industry solution looks like, the industry solution we have in the US. And blockchain enable is one I developed based as close as possible to the conventional solution. And now we have 2 different groups of participants, which are going to be using these 2 different systems to answer to 12 different information queries, which are basically queries about the amounts of payments. So I ask everyone about the amount of payments under a different scenario, and I would score their performance using 3 metrics. So now let me tell you about those queries and the metrics we use. So the queries are basically asking individuals about amount of payments. For example, in the first case, you see we're asking about the amount of payments to the GC in the month of July. As you go down, you see the granularity increases. Sometimes we're asking about particular trades. For example, you see Johnson Group, that's one of the subcontractors. Sometimes we see metal furring, that's a more specific questions. Sometimes we're asking about all the work performed in a given week. So we're trying to see how these 2 different systems compare if we increase granularity. So we have the lowest granularity, which is the first 3 queries. We have low, high, and highest. So we define 4 different levels of granularity. And we score participants' performance using 3 metrics. Are they able to accurately retrieve the information, the amounts of payments, how likely they are to retrieve that information, and how much time it takes to retrieve that information. So far we have everything we need. Let me show you the results, how these 2 different systems compare in terms of visibility. So interestingly, if you look at the 10,000 foot view of projects, monthly, for example, monthly payments to the GC, blockchain provided no benefit over the conventional solution. So if you're asking about payments to GC in the month of July, and that's all you need to know, you better not invest in blockchain. It basically means you're not going to be more accurate, more likely to retrieve the information, and it's going to take you the same amount of time. You see, we actually use t-test to make that comparison. Interestingly, if you increase the granularity of your queries, so that's low, high, and highest, then you see blockchain starts to shine. So if you look at completeness, which is the likelihood of someone being able to retrieve information from a payment system, and if you look at those 4 levels, we see at the lowest, we have absolutely no difference, but as you increase the granularity, we see significant difference. So let me show you some examples. For example, if I ask you about payments to the general contract in the month of July, you're as likely to respond to this if you're using blockchain or a conventional solution. If I ask you about the framer instead, then you're 3 times more likely to respond to this if you're using blockchain. If I throw in something about the scope of work, for example, metal fairing, again, you're 3 times more likely to respond to this using a blockchain solution. And if I ask you instead of July, I would ask you about a particular week, then you're 6 times more likely to respond to this question if you're using blockchain. This is also similar when it comes to accuracy. So basically, people's average accuracy when responding to queries, no difference when it comes to the lowest granularity, but significant improvement when we're looking at queries that are very granular. So the implication being, if you're a company that needs that level of granularity when it comes to retrieving information, then blockchain could be, I'm not saying it could be a solution for you. There's other caveats you have to consider. Interestingly, also, we see that while accuracy and completeness were improved, latency, at least the way we define the queries, were not improved. So we do see some reverse trend in that blockchain happens to be faster at those 3 levels, but the difference was never statistically significant. Putting it all together, we see latency, the time it takes to retrieve the information for this particular definition of a query wasn't impacted. At the lowest granularity, that is a 10,000-foot view of projects, when you're looking at all scopes of work for a given month, no particular impact. Really doesn't make sense to use blockchain. But we see a lot of improvements when it comes to those other types of queries, both in terms of completeness and accuracy of information. And the question I ask is, why do we observe that information? And this is something that I detail in one of my works, but basically blockchain helps you preserve the granularity you already have in your product flow and extend it to your cash flow or payments. So if you look at payments as a transition from product flow to cash flow in the conventional payment solution, even if you have granular progress data, which the drone gives you, you would lose that because you would aggregate everything. Whereas in the blockchain, you have this possibility of directly going from product flow to cash flow, and that is really what's going on here. And needless to say that neither system can create granularity out of thin air. So if you have bad data, blockchain is not going to help you at all. So the implication being that if you have granular progress data, and I can tell you from my experience, very few companies actually have that data, then blockchain could make sense for you if you need to ask very granular questions. So here's some publications that you might be interested to read a little bit more. The first two actually cover the why and how of smart contracts, which I didn't talk about today. The second, the third and fourth talk about visibility, one of which is my PhD dissertation. And the last one is impact on integration of flows. I would actually drop a link in the chat after my presentation where you can access the files. And if you don't have academic access, let me know and I can share the files with you. Lastly, I just want to thank you all, but also leave you with a message in that I would caution you all to be very careful when looking at blockchain research. This is one of the technologies that happens to be quite overhyped, quite overpromised. And honestly, 90% of what I see out there, whether in construction, other areas outside fintech, don't really need a blockchain. Those that actually need blockchain happen to be quite poorly executed. So be very critical every time you see a project about blockchain. It has potential when it comes to fintech, but we have to be really careful when analyzing the data. So thank you all, and I would love to get in touch, be in touch with you. This is my email address.